Hi, and welcome to Jerry's Engineering Corner. I'm Jerry DiBattista, and I am the Global Vice President of Porex Virtek PTFE Business Group. Today I want to talk about debubbling or degassing of fluid streams. Vapors trapped in fluid streams can cause a myriad of issues in many applications where accurate and consistent fluid flow is critical. Even though this topic is extremely broad and its applications in many industries, today I'm going to focus on how this issue affects diagnostic microfluidic applications. Microfluidics is the approach of managing fluid and air in microform, where subtle interactions of design and materials can cause major impacts in fluid dynamics. Air bubble occurrences are considered the most common issue in these devices that can be caused by things like complex microchannel geometries or chip housing material types. These bubbles that can form are troublesome in diagnostic testing, as they can cause poor or inaccurate optical detection, disruption in reaction chamber mixing, can cause vapor lock in the system, block channels impacting sample volume accuracy, and can cause expulsion of reagents. Bubbling can be avoided by very carefully handling of samples and fluid management, but fail-safe mechanisms like bubble traps or active venting are preferred to ensure mistake-free testing. According to numerous experts, Porex Virtek PTFE membranes successfully remove bubbles in microfluidic devices better than virtually any other membrane material tried, in both passive and vacuum-applied settings. Shortly I'll share a video that demonstrates how PTFE membranes successfully remove bubbling in a typical microfluidic design. But first I want to show you the device. So we commissioned a microfluidic chip to reproduce typical conditions seen within a microfluidic cartridge or chip testing device. So this chip is designed with 1 millimeter microchannels. It includes a T-junction channel which replicates complex mixing that are known to create bubble occurrences. The chip has various nodes for pumping air. Air will be pumped in here. Pumping fluid. The fluid will be pumped in here. Pulling a vacuum. This will be the receptor where the fluid comes out. And of course, the bubble trap or debubbling device made with Porex Virtek PTFE. To replicate the occurrence of bubbles in a microfluidic pump is set to desired PSI, vacuum, and air ranges and creates a stream of bubbles that you'll see here from strokes of air and liquid into the system. These bubbles are now stuck in the system, and as you'll see from the video, the debubbling mechanism made with Porex Virtek will remove the bubbles before it goes to the exit channel. Okay, now you can see the fluid flowing in the video, and you can see the bubbles forming and how the bubbles are now being trapped in the system. And as the system keeps pumping the fluid and the air through, as you can see, as it hits the Porex Virtek PTFE bubble trap, the bubbles are removed and pulled out of the vacuum, and the liquid is remained bubble-free, which will then go to the optical or whatever downstream to do the testing, the final testing and evaluation of the sample. And as you can see, the Porex Virtek debubbler is working extremely well. No air is passing beyond the bubble trap, and it's completely free of bubble, which makes detection of that stream very, very easy and accurate. We took this further and tested a system in various pressure frequencies to understand what the lowest possible pressure will Porex Virtek PTFE degas and what internal pressure is considered too high where the vented porous membrane fails or begins to leak. Porex Virtek PTFE successfully removes bubbles even at very low vacuum conditions of 0.5 psi and will keep liquid inside up until about 12 psi. These results are considered optimal for microfluidic-based devices where bubble traps, higher limit pressures ranges between 5 and 7 psi are most common. Results vary depending on the speed of bubble formation, flow rates, liquid types, concentration of mixes and liquids, additives such as surfactants or alcohols can cause issues, and the overall design of the microfluidic device. But for point-of-care test device or anywhere where mitigating bubbles or degassing is critical, don't take chances and consider a vented mechanism in your design using pure, clean, and durable Porex Virtek PTFE. Well, That's it today for me, Jerry with a G.